Okay guys, I left that linear search right there, so we'll continue with binary search. So binary search, let me give you an example. Remember the example that I gave, like you have a pile of books. So in that pile of books, you just know the title of the book. So in that title of the book, you'll just search every single book and search whether the title matches or not. So that is like very tedious if you have a lot of number of books. But imagine you're stepping into the library. There will be separate shelves for different subjects of books, and in those shelves itself, the books would be arranged based on the author and like with the subtopics themselves. So it'll be a lot easier if you just divide it into subcategories and sort it out and then try to find your book. So the same way, binary search uses sorting algorithms to take a sorted list and then find the target element right in that sorted list. So let's just look at a quick example to understand what binary search does, and then we'll dwell into the algorithm. So first we'll have a target 8 and we'll have a sorted list 1 to 11. So 1 to 11 is sorted, and it has basically it has 11 digits here, and the index number is starting from 0. I've written it just at the corner as a tiny number, so it starts with 10. So what binary search does differently is it takes three other variables: start, mid, and end. So start obviously is the starting element of the list, end is the ending element of the list, and middle right here is found with this formula. So mid is equal to start plus end divided by 2. So the start here is not this number, it's the position, the index value of the number. So start would be 0, end would be 10. So start would be, so mid would be 0 plus 10 divided by 2, which is 10 by 2, which is 5. So in this case, 5 is the number 6. So the fifth position would be middle. So now the target would be first, it will be, the target would be compared with the mid value. Okay, so the target would be compared with the mid value. So let's compare 6 and 8. So 6 is the mid value and the target is 8. So is 6 equal to 8? 6 is not equal to 8. That is false. So that basically, if 6 is equal to 8, your binary search will just end right there, saying the sixth position, the element is found in the fifth position, and it will end right there. That is if the target was 8 and this was supposedly 8, but it is not 8. And so the next thing, since they are not equal, it will check if it's greater than or less than. So the target value is 8 is greater than the middle value 6. So since it's greater than, it will just take the right half of the list. So this is what binary search does differently. As the whole list is sorted right here, it's basically using the logic that if the target value is greater than the middle value, then obviously it will be in the right part of the list. Since this is sorted, it cannot go there because the middle value will obviously be greater than the values before it. So if the target value is greater than the middle value itself, then there's no need to compare it with this. You can just directly compare it with the values that are greater than the middle value. So that is the logic being used here. So since 8 is greater than 6, we are just going to focus on this part of the list right now. So I'm just writing that here: 7, 8, 9, 10, and 11. So start will be, 6 was mid, right? The mid was 5th position. So start would be 5th position plus 1 position. We don't want to take mid because we just 6, because we just compared it with 6. 6 is not equal to 8. So we don't want to bring that again. So we're just giving that position plus 1 as start. So start would be 5 plus 1, the 6th position. The end would not change, and then the mid will be calculated again with the same formula. So now it's 6 plus 10 by 2, 16 by 2 is 8. So at the 8th position, we have 9 right here. So that's our new mid. The same procedure as here. This mid will be compared to the target. So is 9 equal to 8? No, it is not equal to 8. So it'll check if 8 is greater than or lesser than 9. So 8 is lesser than 9. So we'll consider the left half. So that is this part of the list right here. I hope I'm being clear. So this part of the list, I'm writing that down, 7 and 8. So this would be the start. The start would be unchanged. And the end value, now since we already compared with 9, we don't want to take that again. So we'll instead, this index minus a value. So 7 would be end. So the start and the end would be here. The same way mid will be calculated as start plus end by 2. So 6 plus 7 divided by 2. that is 13 by 2. Since this is an integer value, 6.5 will be converted as 6. So the sixth value 7 would be considered as the mid value. I hope you understand up till this. So again the same procedure. Is 7 equal to 8? No, it's false. So it'll see if 8 is greater than 7 or less than 7. 8 is greater than 7, so the right half of the list will be considered. The right half of the list is nothing but 8 right here. So we're writing 8 here, and the start and the end are the same value right now. So that would be your condition for the while condition. So while start is not equal to end, you would do all these calculations and all these comparisons right here. But once start and end are equal, you end up with only one value. So that one value, it may or may not be equal to the target value. So you have to do just one last comparison. In this case, it is equal, so I'm just giving position is equal to 7. But if it's not equal to that, it may or may not be equal to that. So in that case, you have to do one last comparison. Since start and end are equal, I'm just giving that list of start is equal to target in an if condition. So if this is true, I will give position as start, and I will give that the element is found at that position. Else I will give position as -1 and that the element is not found. I think I rushed a bit here. I hope I'm clear. If not, I'm just going to go through the algorithm again. I will come back to an example later. Alright, the algorithm right here. So, wait, I just covered this so it'll be easier to follow, so you won't be scared by such a huge thing. So the binary search algorithm, so let's first start the program as step 1. Then step 2, we are getting a sorted list. So if the user might give an unsorted list as an input, in that case just add an extra step between here to sort that list. But we are just searching here, the algorithm is just for binary search, so the sorting step isn't really necessary. So I'm just getting a sorted list as list and the target as target. Then the step 3, I'm initializing 4 variables right here. So I'm initializing start is equal to 0, as the list 0th index would be start. End is equal to n, where n is the length of the list, so end is like the last element of the list. Mid is equal to -1 and position is equal to -1. So mid, why I'm giving -1 here is I'll be calculating mid every iteration through the while in the while loop. So next we have the while condition right here. So while start is not equal to end, repeat steps 5 and 6. So that condition I just explained earlier. So when start is equal to end, we would only have to do one last comparison. But until that, we would be doing the comparisons and halving the list as we compare it with the middle value. So now inside the loop, we have step 5, calculate mid is equal to start plus end divided by 2. So now we're calculating it. So here in this case it will be 0 plus n, whatever value that is. So 0 plus n divided by 2, assuming n is some like 5. 0 plus 5 divided by 2. 5 by 2 will be 2.5. Since it's an integer right here, this will be an integer, it will take it as 2. So we'll be calculating mid right here. And then step 6 would be an if-else statement. So here the if statement is if target is equal to list of that middle value. So it will be comparing it with that middle value, and if that middle value is equal to target and that is true, then position will be equal to that middle value right here, and it will print that the element is found in that index right here in that position. And then it will go to step 8. Step 8 is exit the program. Else, if this is not equal to, that is if the target is not equal to the middle value, then it will just check if it's greater than the middle value. So if target is greater than the middle value, then we would be changing start from 0 to middle value plus 1. Else, in the sense, target is less than the middle value. So if target is less than the middle value, we'd be changing end as mid minus 1. So this entire thing is just an if statement, so it's entirely step 6. So if this is true, it will be exiting the program after printing the position. If that is false, then either of these would be executed, and depending on which executes, it will just start the loop over again, and it will be calculated, and the whole comparison will go on and on. That is until start is equal to end. So once start is equal to end, we move to step 7. So step 7 right here, we're just giving if start is equal to end, just as to be on a safer side. because it'll be a bit tricky to code this stuff, the binary search. So if start is equal to end is true, then go inside the loop. Then the last comparison, if target is equal to list of start. You could also give list of end because these both are the same. So if target is equal to that is true, then we are changing position to the start value and printing that position value. That is the element is found at that position, and we are moving to step 8, which is exit the program. Else, that is, if the target is not equal to that last value that we have gotten, then the position would be -1. That is, the element has not been found. That is, the element does not exist in the list given. So this is the algorithm